Welcome to another lesson on class hierarchy and interfaces in Java. Now that we have a good foundation in classes and inheritance hierarchies, we'll discuss interfaces, which is yet another feature of Java. After completing this lesson, you'll understand the similarities and differences between Java's class and interface features, so you can evaluate programming problems and apply the best solutions. You will also be able to provide examples that contrast between these two features. Finally, you'll also know the proper syntax needed to implement the interface features presented in this lesson. So let's get started.
Once again, it's much easier to discuss the ideas of object-oriented programming in Java if we have an example in front of us. Consider these 4 objects you might find in a to-do list app that helps to schedule items: an errand, a bill, a workout, and a social engagement. Each has a very different way to define the state of the object, and so each has different fields. We can't even say that their behavior is necessarily the same, but the way in which clients would interact with these objects is the same. Each of these objects can be scheduled on a particular date, and each can be marked as completed. They may also have other unique behaviors, but we want to focus on what they have in common. Clearly, these items cannot be arranged into a hierarchy. Superclasses and subclasses won't work here, but we should be able to take some advantage of their similar behaviors. For example, to schedule an errand, we would consider the deadline, the time it will take to complete, and then try to find a time slot that works. To schedule an engagement, we might check the requested date and then generate some sort of RSVP. In both cases, we'd like to keep the call to the schedule event similar and simple. This keeps code readable and easy to write. Although a hierarchy is out of the question, we can still take advantage of some of the benefits of code reuse by designing an interface. A Java interface includes public method headings, that's name, return type, and parameter list, but it doesn't include any body, no implementation. Like this method header for the method completed. This is all that we would see in the interface. Interface name should be capitalized. The file name and the interface name must match, just like a class file. And the file you write will end in .java, again just like a class file. But there should be no constructors, no instance variables, nor any bodies of any of the public methods written. Interfaces will never be instantiated. They do not contain the necessary information to create an object. They act as a form for methods that implement that interface to follow when it comes to defining methods. You can see what I mean in the next slide. Here is an interface called item that includes 2 public method headers, schedule and complete. These are 2 behaviors that will be common to all the classes that implement this interface, but the implementation details of how each class accomplishes the method will be quite different. The class errand implements the interface item. Errand can have instance variables, constructors, accessors, and mutators necessary to model the class, but it must also implement all of the methods listed in the interface. In this case, we have 2, schedule and complete. Another class, engagement, also implements the interface item. Its instance variables and methods can be completely different from those found in errand, but it must also implement the 2 methods provided by the interface. There is no inheritance at work here, like we saw between superclasses and subclasses. Instead, we have 2 classes, errand and engagement, that both invoke the same method, schedule, but with 2 very different implementations. Finally, an interface can be used as a parameter type. Polymorphism makes this possible. Because every class that implements the item interface is an item, it can be passed as an item to a method. Here is an example of a method that tries to reschedule any unfinished items for tomorrow and mark them as complete on today's list to close out the day. Because each of these items can implement both schedule and completed, we could pass an engagement, an errand, or any other object that implements the item interface.
You have now added knowledge of interfaces to your growing knowledge of Java object-oriented programming features. Now that you've completed this lesson, you should understand the similarities and differences between Java classes and interfaces. You should also be able to provide examples that contrast these two features. Finally, you should know the proper syntax needed to implement the interface features presented in this lesson. As we wrap up this lesson, try coming up with a couple of scenarios where a Java interface would be appropriate. For example, developing classes of shipping containers, like flats and boxes, could be facilitated with a shipping container interface that included methods for capacity and dimension. Try designing a few interfaces yourself. Be sure you aren't simply designing a class hierarchy and burdening it by forcing an interface where one is not needed.